So welcome everybody today to today's webinar. The topic of today's webinar will be Recon Oil. Recon Oil is a really exciting new acquisition for SKF. We were acquired back in 2019, excuse me, back in 2019. And at that point, really a small company, but doing really exciting things in Sweden, regenerating oil and cleaning oil down to a really high standard. Since then, the company has grown dramatically. I think we're up to a headcount of about 50, and we're starting to use SKF's wider network to try and deploy this technology globally around the world and really take this exciting technology to our customers. So I'm really happy today to be speaking to you about Recon Oil. But before I get into today's topic, let's go through some of the practical details, ground rules. What I would ask is if you have any questions during the webinar, Teams does have a chat function. Please use that for raising questions. If you want to react or interject or disrupt during the webinar, I'd encourage you to use the raise your hand option at the top of the screen. I would also ask that you turn off your camera and mute your microphone to avoid background noise. And finally, it's just a reminder that this webinar will be recorded and will be shared afterwards. We do run a schedule of webinars. We're coming to the end of the calendar year. There's only one webinar left to come out. I believe the topic is to be confirmed, but it's just a reminder that we do also have on-demand webinars available covering 2020 and 2021, the pandemic years. To give you an idea of what you can find in the on-demand webinar series, from remanufacturing through to connected technologies and condition monitoring, we have webinars. I feature there already, so if today wasn't enough for you, you can find me again in railway-specific webinars looking at railway condition monitoring, covering remote diagnostics and some of our cutting-edge sensorization products. This is just a hint. There's a lot more than just this, but they won't fit on one slide. In terms of sales representation, if you already deal with SKF, some of these names will be familiar to you. We do have a regional split, so there's a number of regional sales managers. If you have any questions, comments, or interest in any of the SKF products, Recon Oil or bearings or condition monitoring, please feel free to reach out to anybody on this list. In terms of Recon Oil, obviously I'm based in Dunfermline in Fife, so in Scotland, and I'm available to support. I'm part of a global team supporting Recon Oil, but lucky for you, I'm local. But we do also have other local champions supporting the Recon Oil product and service range. We've got Neil Curran and also Gavin. They also support connected technologies service delivery, so please feel free to reach out to them in that area too. A bit about myself. I joined SKF back in 2012. Initially, I joined as an application engineer, and some of my first jobs were climbing up wind turbines all around the world, installing condition monitoring systems. That particular picture on the left was taken up a turbine in Bulgaria, but I've been on up turbines in India and all sorts of places globally. It was one of the most fun things, I should add, that I did being in the company. Really quite exciting. After wind, I moved into the area of railway. And I've worked in railway in a global team developing business around new condition monitoring products in the railway market. I supported the delivery of SKF Insight, which would be a completely wireless system for railway applications. You can see it in the top middle picture. I was also part of the validation of these systems. I made the first detections with the Insight system, and again you can see the bearing just here. That was a bearing which I detected as an analyst, and as I progressed through SKF, I've also moved more into business development areas, and in more recent years I've also joined Recon Oil. So I think I've been Recon Oil 6 months. It's my anniversary, woohoo! And it's really been quite exciting, a big jump away from condition monitoring, but they really are doing good things in this team, and it was well worth taking the risk jumping across. And when I'm not doing all these wonderful things for SKF, you can usually find me out in the woods around Dunfermline, exploring, foraging, doing all sorts of things in the natural world locally. If you want to contact me about Recon Oil or any of our offerings around SKF, feel free to reach out to me. I am available. on LinkedIn. I am based in Scotland, and in principle I can travel to you if you have interest or if there's particular applications that you're interested in. So please do feel free to reach out to me. But getting back to the topic of today, Recon Oil, a sustainable use of industrial oil. It's very much an intuitive concept that things degrade over time, that they age and in turn eventually expire. And there's been talk forever, I would say, since the beginning of time around the notion of infinite life and extending life, the philosopher's stone. So allow me today to talk about the proverbial philosopher's stone in the context of oil. However, while the philosopher's stone may be a fantasy concept in the real world, when it comes to when it comes to oil, really the concept of using oil again and again and again, having truly circular use of oil, it's something that's well within reach, and Recon Oil are leading the charge in pioneering infinite, or certainly extending significantly, the life of oils by cleaning it. If we consider oils, it's intuitive, again, that in operation they will become contaminated, they will degrade, they will oxidize, to such a point that eventually they will be taken out and replaced. And this is perhaps not the best use of a non-renewable resource. And what we would like, certainly in the realms of sustainability, we would like to move away from discarding these sorts of resources. And oil, there's no excuse for discarding oil. If we look at the wider movements, again, against the backdrop of the recent conference in Glasgow, circular economy is increasingly becoming more relevant. If we look in Scotland, we've got the Zero Waste Scotland initiatives. If we look across other industries like steel and plastic, there are initiatives to try and reuse materials that are used in those processes. So my challenge to you is, why don't we apply the same rationale to oil? Oil doesn't need to be discarded. It doesn't even need to be changed out. And with Recon Oil, we can show you how this can be done. But first, imagine what the impact would be if we didn't need to discard oil, if the lifespan of oil could be endless. First of all, if you're filling your tank, that's new oil. That's new oil that had to be extracted. That's new oil that had to be transported. Imagine if we didn't need to refill the oil, or we didn't need this oil to be moved to your facility. It would have a direct saving on your budget, so you don't have to buy new oil. But similarly, the carbon consumption that your company needs to track, it would be significantly reduced if you could avoid buying new. But of course, there is an argument out there that oil is a small cost. It's only 1 to 2% of the maintenance budget. So why should we invest this sort of attention and focus on oil when it's just a small cost? The response to this, the rebuttal, is that it's not sufficient just to consider the direct costs. There are indirect costs as well of industrial oil. Oil is omnipresent, I would say, in industrial processes, and the quality of oil has a direct impact on the quality of the machine and the quality of the process. So if you have poor quality oil, you'll end up with an unreliable machine and a variable process, and that's something we'd like to avoid. So if we can ensure that oil is always kept in a very clean state and isn't allowed to degrade over time, then we can avoid some of these indirect costs of oil, costs like product variability, scrap rates, rework rates, unplanned downtime, maintenance costs, machine repairs, as well as high energy use. If your oil has contamination in it, it will have increased friction, and you'll end up with higher energy use as well. So if we can remove contamination from the oil, we can also reduce energy consumption. Also, if you have more reliable machines, more reliable processes, it allows you to give more confidence to the lead times you're giving your customers and avoid delivery failures and customer complaints. So really the impact of oil is quite significant. In terms of SKF, if we consider our own facilities where we're already deploying Recon Oil, we're already avoiding scrap, which would have occurred due to unclean oil, by by cleaning the oil, we're able to avoid this scrap, and that argument can be applied across many different industries and applications. If you have clean oil, you can avoid scrap. The indirect cost of oil can amount to some 40% of the maintenance budget. So let's get rid of this too, for good. Let's make it happen. I'd like to introduce Recon Oil, a truly circular use of oil, which is enabled through double separation technology. More of this to come around what double separation technology is, and which is brought to market with a service business model, which we call oil as a service. Abstract notions, but oil as a service really puts us in the same area as Netflix. What Netflix has done to movies with a subscription model for accessing TV on demand, we're giving you oil as a service with a subscription-based payment model. But first of all, let's consider our revolutionary double separation technology, which underlines all of our products and services that we're delivering. First of all, to understand the impact our double separation technology has and why and how it works, we need to first consider some of the degradation mechanisms that happen with oil. So it's intuitive that oil can become contaminated. When you have mechanical components moving, wear particles will be generated. You will have water contamination, air contamination, energy contamination into the oil, which can lead to degradation of the oil. You have oxidation, which is correlated with the aging process of oil. As oil gets older, it oxidizes. A bit like the apple at the start, when you see an apple browning, the taste goes. When an oil starts to oxidize, you start to get varnish deposits, which can clog your system. It can clog valves, it can clog heat exchangers, and generally can lead to poor performance, a more rapid deterioration and wear in the mechanical components. It can also lead to additive depletion. So additive depletion is another degradation mechanism. Now, all of these degradation mechanisms are closely related. So contamination can lead to oxidation, and oxidation can then cause antioxidant additives to deplete. Oxidation byproducts like varnish can also cause accelerated wear, which means that the anti-wear additives can also be more rapidly depleted. So actually there's a chain effect here that can occur with these different degradation mechanisms. If you'll allow me to focus in on oxidation, it's complex, and you'll hear people talking about the production of different acids when oxidation occurs, which can then lead to the formation of sludge and varnish and different deposits within the system. Now, there's a whole family of different chemical compounds that can be formed here, but in a very simplistic model, they go under the umbrella terms of sludge, varnish, and deposits. And as I mentioned before, the impact these byproducts can have is quite significant. Varnish, like I mentioned, can clog valves, it can clog heat exchangers, causing overheating in the system, and again accelerates the degradation of the oil. It can also lead to staining of workpieces in metalworking applications, leading to inhomogeneous finishes and poor finishes of the product. And it's something we'd like to avoid. So yes, it is a complex process, but at a very simplistic level, there's three factors that you could consider that gets the ball rolling, the oxidation ball rolling. Oxygen, which can come in the form of air or water contamination. They can supply oxygen into the system. So this is why quite often in oil lubrication systems, you have the likes of desiccant breathers to try and limit water contamination to the system. Also, you have closed systems limiting exposure to the air. You've got energy contamination. This can be high temperatures or UV light, which in turn can cause oxidation to occur. But what's also quite significant is wear metals or metal particles. So when you have metal mechanical components moving together, they will generate metal particles through the process of wear. And these metal particles can initiate the oxidation reaction in oil. And not only that, the second stage of oxidation, which is propagation, wear metals can act as catalysts in the propagation stage. This means they help to speed up the oxidation process, and it accelerates in the presence of wear metals. So what we would like to do is remove metal particles from our oils. And obviously that's not the only reason, because metal particles can also cause abrasive wear within the system as well. So it's well established that we need filtration in oil systems. But when we talk about conventional filtration systems, typically they're limited in their performance. Even the ISO cleanliness codes go down to only 4 micron, and even the cutting edge of filtration technology, if we look at electrostatic filters, typically they go down to 1 micron in their the range in which they can filter. So they're able to remove these particles, but what's important to consider here is that typically particles which are in the micro domain only account for about 20% of the surface area of contamination. And intuitively, surface area plays an important part in the speed of a reaction, and certainly in a catalyst, a catalytic reaction. The analogy which always comes to mind is if you get a tablet, put it into water, it will take some time to dissolve, but if you crush it and then add it to water, it should dissolve much faster. Applying the same approach, nanoparticles, they account for 80% of the surface area, and yet conventional filtration struggles to manage these particles, and yet they play the more significant role in this initiation and propagation stage of oxidation. They help to catalyze the reaction. So why aren't we treating it? Now, what I'll be presenting today and why Recon Oil is exciting and a little bit different is because we pay attention to the nanoparticles, and this is really where we excel. By removing the nanoparticles, we can really slow down and impair the oxidation reaction and stop oils from aging. So I talked about double separation technology. It's built on 2 principles, attraction and gravity. So if you consider a contaminated oil, so the oil is represented here with a white circle, and the contamination with smaller particles just here. We add to this oil very small volume of a chemical compound which we call a booster, DST booster. And when I say small volumes, you're talking about in the range of 2,000 parts per million ish added to the oil. And when it's added to the oil, what happens is it causes these small nanoparticles to come together, coagulate, and sediment then out of the oil. So by increasing the density of the particles, making small particles form bigger particles, they can then fall out of the oil. And what results is ultra clean oil and minimal waste. And if we do this continuously, we can then talk about the circular use of oil, because we're stopping this oxidation process from happening, from initiating, by removing these nanoparticles within the oil. And it's all very abstract and theoretical until now, but just to give you a very quick idea of what this actually means, quite intuitively, if you look at this moving from left to right, the used oil on the left clearly has a milky look to it. It's clear that it's dirty, let's say, and after a single pass process through our DST system, you can see that it's been significantly cleaned. In this example, it's 99% of the particles have been removed. So it's a significant step change moving left to right. Now, I would say that 2021 was a significant year for me. So I joined Recon Oil. Like I mentioned, I come from a vibration condition monitoring background, but I also took up a new hobby, and the parallels between oil and wine certainly come to mind. And I've also taken up homemade winemaking. And this particular example is a slow wine. And most of you will probably know slow gin. Here I'm making, in fact, it's slow mead. So I've used honey. But the principles that I'm describing here are quite similar. For any of you who've done this before, you might have heard the term finings, which is when you add a chemical compound to, let's say, the colloidal suspension within wine. So this protein suspended in the wine makes it give this milky look. When you add in finings, it causes the protein to come together and then sediment out of the wine, and you end up with a lovely, clear, bright wine. And this is what we strive for if we're making wine. And the principles, to a certain extent, are similar. Certainly in winemaking, you hear people talk about activated clay, which operates in a similar principle. Our booster is polar, and the parallels are there certainly in winemaking. So it's just an example that I use sometimes to rationalize what I'm doing, because I can certainly see the parallels with my own hobbies. But if we go back to oil, I should add that if we remove the particles from, similar to removing the particles from wine, but if we remove particles from oil, then just like a good wine, it should improve over time as we process it with the DST system, which is contrary to our engineering experience. We expect oil to degrade over time, but if we do clean it, it should last. It should be treated as an asset. Just to reiterate the point and what makes us a little bit different. So if we talk about other filtration systems on the market, the likes of high-speed separators, typically they can only remove particles down to about 5 micron, coated filters 2 micron, electrostatic filters down to 1 micron, and DST takes a step much further beyond this. So we're removing the much smaller particles. And when we're removing such small particles, the reason why this is also relevant for us, when we talk about oil, and I've mentioned varnish earlier, varnish is one of the byproducts of oxidation. But it comes in two forms. This can be in a hard or a soft form. Typically, soft varnish is in solution, so it's very small particles, typically less than 0.1 micron. But if DST can remove nanoparticles, we can also address the soft varnish issues within oil as well, which also separates us from the other filtration systems that are on the market. And of course, if we're removing these nano-sized particles from the system and constantly cleaning the oil and doing this again and again and again, we can really start to talk about the circular use of oil. And this underlies all of the systems and services that we supply. Double separation technology is what we lean back on because it allows us to discuss the circular use of oil. And for those of you who might wonder why cleanliness is important, even if we consider in the ISO domain, now ISO considers particles greater than 4 micron, if we move from cleanliness level of 23, 21, 18, by the way, for those of you who aren't familiar with these numbers, they describe the particulate contamination of at different sizes. But if we move from this cleanliness level across to 14, 12, 9, it can lead to significant increases in the life of the oil. So by a factor of 4 or 5, 7 or 10, depending on what application we're talking about, be that gearboxes, rolling elements, journal bearings or hydraulics. But certainly improving cleanliness has a direct correlation with extending the life. And of course, these sort of tables, this one we got from Noria, but other calculators or tables are available from other providers. But if we start to step beyond the constraints of the ISO cleanliness codes and start to talk about the nano domain, you can only imagine the sort of gains and increases we could achieve. It is significant. And it's worth highlighting as well that a lot of the tests which are designed around cleanliness and testing oil and condition monitoring, they really are limited in the particle sizes that they consider. So I talked about the ISO cleanliness codes. They only consider particles greater than 4 micron. What about the nanoparticles? What tests are available for them? But also varnish. If we talk about varnish potential, there's this test called the MPC test, which is similar. I always compare it to a coffee filter. The darker the color of oil which passes through this membrane, so oil passes through this membrane and captures residue. The darker the color, the greater the varnish potential and the worse condition your oil is in. And there are grades which are attributed to these. In this case, 8.4 on the left, 3.6 on the right. Now, generally, any MPC grade lower than about 15 is acceptable. But is good enough really good enough? Are we really capturing the full picture here? Because these MPC tests are constrained to a pore size greater than 0.5 micron. And we're talking about nanofiltration here. So we've actually had to invent tests to try and demonstrate our own performance. So what we do is we add to the oil samples a small amount of our DST booster, which causes these smaller particles to coalesce, to come together. And then we run it through the MPC test. And you can see that this is a significant step change. That really, before it was difficult to see the impact our DST process was having. And yet, when we do this, let's say, additional test, you can see that the difference moving left-right is much greater. So although the MPC grades are within acceptable rates, there's definitely dissolved or soluble varnish potential on the sample on the left, which we've been able to process and remove with our DST process. So we're really taking it one step further with our nano polishing technology. And again, I've certainly gone way off down the deep end of the theoretical end of the pool. So at this point, maybe it's a good idea to introduce one of our customer cases, and this case comes from ZAP in Sweden. Now, ZAP produce stainless steel wire, and here they've got particular demands around precision. And prior to having a Recon Oil system installed, there was a 12-week cycle on oil which was used when drawing this steel wire. And typically what happened was that over the course of that 12-week period, the oil would become increasingly dirty, and that would have a knock-on effect on the quality of the product which was being produced. So the best quality product would be produced at the start of this 12-week period and the worst quality at the end of the 12. So this variability obviously is something that manufacturers don't want, but also replacing oil every 12 weeks is perhaps not the most efficient use of oil. And this led them to Recon Oil. So they've installed a continuous system. So we have two types of systems, and you'll see more about this later. We've got batch treatment, where oil can be processed at a plant and returned to the machine, or we can have a system which plugs directly into the reservoir and continuously cleans, like a kidney, the oil within that system. So they have a continuous DST system installed, and I think it's 2012 when the system was first installed, and since then they've been able to avoid 40 oil changes, which is quite remarkable. An 88% reduction in their scrap rate, which again is significant, along with 25% improvement in their productivity as a direct result. And obviously, if they've been able to avoid all of these oil changeouts and avoid the scrap rate reduction, have the scrap rate reduction, it has had a positive impact on their environmental profile. I believe there's two facilities. So there's one in Sweden and one in Germany. It's the Swedish facility where we have Recon Oil installed, and some of the machines there are 50 years old, or they're old machines, and yet they have some of the best results or quality rates within ZAP, and certainly comparable to some of the more modern facilities that are there. And the environmental profile is very good. Obviously, with the evolving situation at the moment around sustainability, having a system that allows them to have a circular use of oil certainly allows them to keep track and stay ahead of some of the changes in policy. And also the facility has maximized uptime because they've been able to avoid changing oil so frequently. So as a direct result of having the Recon Oil system in place, they've had much less variability in the product that they're producing, and they've been able to avoid a significant number of oil changes. But we're not limited just to metalworking applications. We've also had results with hydraulic oil. And just to give you an example here, moving from left to right, a cleanliness code of 252315 to 14108, it's a significant improvement in hydraulic oil. And this comes just from our a single pass-through proof of concept system. And you're talking about removing in the region of more than 95% of the particles within the oil, just considering the microparticles. We do, obviously, our selling point is in the nano domain. So this level of cleanliness extends right down into the nano domain as well. What we've been doing, we recently commissioned a test in our Judenberg facility in Austria. Now, Judenberg develop sealing technologies for hydraulic applications, but they also have advanced test rigs for testing seal performance. And we ran a test to see what sort of impact oil that's been cleaned with our Recon Oil DST system has on hydraulic system performance and on seal performance. So we ran a series of tests. Initially, there was a baseline test where we ran the oil over up to 780 kilometers of linear actuation. By the fourth test, the oil had degraded. Well, let's say after test 3, we divided the oil in half. So half the oil went back into the test, we ran it again, but at that point it was deemed that the oil had degraded to a state that was unacceptable. But the other half of the oil was cleaned with our DSC system, and then the test was then rerun. And what we found was really quite interesting. So first of all, this gives you an idea of what we look like in the baseline tests. So you can see there's color changes as we went through the test, the test went further along. And after the third test would be where we would normally recommend an oil change. But like I mentioned before, half the oil we continued to run, and you can see the oil reached a point where it's really very dark, but also leakage spiked, as did friction. So we saw significant increases in both of these domains, which backed up the rationale that oil should be changed after test 3, and that test 4 of the oil condition was not good enough, essentially. The other half of the oil, we then put back into the system after cleaning through a DST system, and we were able to run the test again. And while you can see the color has continued to change, color is not always the best representation of oil condition. What we saw was that we had reduced leakage. Now, what you're looking for in this graph, this plots leakage over distance, and distance is the distance done in the test. And what you can see here, by the 4th test, which is where we recommend the oil would have been discarded, you can see that leakage spiked at this point. This is why we recommend changing it after the 3rd test rather than the 4th, because it started to have an impact on leakage within the system. But what we saw after cleaning it with our DST system is that leakage significantly dropped. So you'll see the numbers here towards the end of the test are significantly lower. Also, what we saw was reduced friction. So again, if you compare the baseline with loop 1 here, you'll see that the numbers are smaller. And similarly here with the baseline, it's smaller. So after a single pass cleaning treatment with our DST system, we were able to reduce the friction as well. Now, friction is important because this is directly correlated with wear. So if we can reduce friction, we're going to reduce wear within the system as well, and energy consumption as well. So there will be knock-on effects of reducing the friction. So this just illustrates some of the advances we're also making in the area of hydraulics. But like I mentioned before, we have a diverse range of products and services. So now's a good time to show you what we can offer. So I've hinted at our continuous system. We have more. If you consider just a plant with a conventional oil system, we have a continuous small system, which can handle tank sizes of 5 to 20 cubic meters. Typically, we recommend these continuous integrated systems for metalworking applications, where the oil touches the workpieces and there's a direct correlation between the condition of oil and the quality of the workpiece which is being machined. So when I talk about metalworking, it's the likes of honing, grinding, broaching, rolling, drawing in this area. Really, continuous systems really excel here. And they come in different sizes, so small and large. The large system obviously can process larger or support larger tank sizes and has a greater throughput, so 8,000 litres per day. We also have a miniaturized version, so these big systems can be a little bit intimidating, but there's a miniaturized version which we dub the Recon Oil box. And the box comes from the original development name. We originally called it the shoebox, and that gives you an idea of its diminutive nature in terms of size. Obviously, because it's a smaller system, it's intended to treat smaller systems. If you think of small closed hydraulic systems, anywhere from 500 litres to 2,000 litres, it's really where we excel with the Recon Oil box. This is quite exciting because it's coming to market in the first quarter next year, and it's currently in a test phase. But it's bringing our DST technology to the market in a much more accessible form. So you can enjoy the nano polishing that I talked about before in a much smaller package. This system is deployed in a similar way to the continuous system. So we talk about these continuous systems being integrated. They act like kidneys, albeit very big kidneys. So they're on kidney loops with the oil lubrication system. The Recon Oil box is also deployed in a similar way. So it's not a full flow filter. It's meant to complement your existing filtration system with this nano polishing technology, acting like a high performance kidney loop. And there are also batch treatment possibilities there as well. And these come in smaller and larger formats or forms. So the smaller system can treat 1,000 litres per batch, and that's in a development phase at the moment. And the centralized system, we have one of these certainly in our German plant in Schweinfurt. It can handle much larger volumes of oil. In terms of the sort of applications that these can be deployed, like I mentioned before, the continuous systems, the big continuous systems, are well suited for metalworking applications, the likes of honing, grinding, cutting, cold rolling, cold forming, stamping, drawing, forging, and quenching. When you've got large volumes of oil, as well as a high demand on the quality of the workpieces and on the cleanliness of the oil, this is where we recommend our continuous large systems. In terms of the batch treatment, the standalone systems, they're ideal also for quenching oils, but also for large volumes of hydraulic oil. And of course, we've also got the Recon Oil box. So we're initially targeting hydraulic oil and gear oil. I should highlight that these applications are current focus right now as we bring these products to market. It's not necessarily limiting the applications that we're targeting. It's just our initial approach to market. If you've got applications which are beyond the scope of what I'm showing here, we are of course interested, and please feel to raise them with us. We have other examples elsewhere where we've deployed DSD systems, so certainly do get in touch. To give you an idea as well of the sort of results and applications, what our performance looks like in different applications. Again, I talked about this MPC test, a bit like the coffee filters. Intuitively, the darker the color, the greater the varnish potential, the poorer condition the oil is in. The lighter the color, the better condition the oil is in. And this is the ISO cleanliness codes. And again, the bigger the numbers you see here, the more contamination, particulate contamination you have. The smaller the numbers, the less contamination you have. So we've had strong results with honing oil, and this comes from our own production lines where we've deployed Recon Oil DSD continuous systems. So this just as an example from the field. So significant improvements in terms of contamination. This one is quite extreme. To hydraulic oils, this is the example I used earlier. Quenching oils. Here you'll see in the MPC test not such a significant change, but in terms of the ISO cleanliness codes, there's been a significant improvement moving left to right. And this example is just in a single pass through the DSD system. So just imagine what the cleanliness would be like if it was continuously circulating. And in the quenching oil example, it's one which is a bit more accessible, which shows you the impact that clean oil can have. It has a visible improvement on the products, which certainly we've been processing internally in our quenching facilities. So you'll see that on the left here were rollers and outer, I think there's this an inner raceway, which have been quenched. And you'll see that there's a little bit of soot staining on the rollers, and also that this raceway down here has a yellowish tint to it. So very much an inhomogeneous surface finish to both the rollers and the raceways. And yet after we've cleaned the oil, you'll see a significant improvement in the visual appearance of the rollers and also the raceway. And this is important when we're trying to sell quality products. Trying to convince a customer that something which has soot staining on it is a quality product is difficult. For those of us who work in the area of metalworking, the finish on the workpiece is important. What we also noticed was that when we processed in this particular application with DSD, we were able to fully recover the cooling curves once we'd cleaned the oils. So there was no significant change. We were able to maintain the properties of the lubricant, but we were able to remove the varnish potential and significantly reduce the contamination as well. So you'll see here, it's in the region of 99% reduction in particles from the oil. I mentioned before that this is delivered in a service type format. We are the Netflix of the oil world. And what does this actually look like, and what does this mean? So we offer it under the term oil as a service, where we take responsibility for the value creation. We have some mutually agreed KPIs, and it's our responsibility to support you as a customer in meeting them. The technology, and you'll see that it is cutting edge technology. There doesn't necessarily need to be an upfront high barrier to actually getting one of these systems. Having a service-based offer makes this technology accessible to you. Also, we offer two business models, one where it's built purely on service type basis. The other business model is based around performance. So if we can reach certain mutually agreed KPIs or targets, then we can also split some of the savings between us so that we're both incentivized to make sure that your oil has the impact that it should have at your facility. Never pay again for never pay more for industrial oil ever again. So and this just gives you an idea of the sort of KPIs which we could consider. This particular case would be looking at a metalworking application where we'll be talking about scrap rates and rework rates. But also, this could be applicable in other domains as well. Unplanned stops, additive use, appearance, etc. So again, these KPIs can be agreed between us. What's important for you and how we can work towards those goals by cleaning your oil. It's just one more thing. It's been very abstract until now, and I know when I do these presentations, one of the first questions I get is, what do these systems actually look like? This system is one of the systems which has been installed in our Eraska facility, and it's a continuous DST large system. What you see here, the large tanks are the sedimentation tanks. And we are in the process of deploying Recon Oil in our manufacturing facilities. This particular example is deployed on our honing production facility, where we're honing bearings. And what we've seen already, we've deployed this, I should say, not just in Eraska, so Tudela, Casino, other manufacturing facilities too. We're in discussions, I should add, also in the UK for having similar systems installed in Luton, but this is very much early phases discussions. But these discussions are being had in all SKF production facilities globally. What we've seen so far are early results after the first 6 months of deploying it internally in SKF, 50% oil reduction. Because we've deployed this on our honing production step, surface finish is very important to us, surface roughness, and we've seen a 20% improvement in the surface roughness after deploying our Recon Oil system. What does this actually mean? The surface roughness has a direct correlation with noise and vibration, so the better, smoother the surface, the quieter the bearings will be. And in some applications, this is an important parameter, and it's tightly controlled in these particular facilities. And what we've seen is there's normally a control step. So if the bearings aren't sufficiently quiet enough, they have to be put back for rework before they can be finished. We've seen a significant reduction in our scrap loss and rework rate after also deploying Recon Oil. We've also seen just under a 2% improvement in our OEE. Obviously, there have been improvements in EHS, and also we've got a much more stable production. And also now that our oil cleanliness levels are stabilized with significantly less variance, it means that there are discussions now about the possibility of reducing the frequency of oil condition monitoring, sampling less frequently, because we've got better control now over the cleanliness levels. What's also significant is that previously there was quite rigorous washing further down the line. After the bearings have been honed, they then need to have the oil removed, and they're put into a solvent for doing that. And we combined the DST deployment with a oil recovery system, so there's no drag out coming from the system. And the combination of very clean oil plus the oil recovery system means now that we can consider removing the solvent cleaning step, which also is good news for some of the downstream processes and also in terms of EHS on site. So with Recon Oil, what we propose is to lead through change. So we're talking about sustainability in industrial oil and the opportunity to please your stakeholders. We're increasingly seeing that stakeholders are interested in your sustainability credentials. Recon Oil allows you to at least go some of the way in doing that, while increasing your productivity and performance. To become more competitive, eliminating the direct oil costs, but also eliminating indirect oil costs, improving your scrap loss rework rates, improving your quality, having more reliable machines, and reducing downtime. And also no more surprises. Like I mentioned before, eliminating oil changes with ZAP. They've managed to avoid 40 oil changeouts. No unplanned downtime as a direct result, and a clean factory environment. In some facilities, it's really important to have a clean environment, and having clean oil is one step towards achieving a clean overall facility. If you are interested, please feel free to get in touch with me. We can have a look at your potential. Usually the first step, if you have an application in mind, is to take an oil sample, where we will then check compatibility with our process. So please send us a sample and we'll go from there. So thank you. That was the webinar.